Hi guys, welcome to today's lesson. So today we're going to be looking at proofs of parallelograms. Firstly, we're going to look at what makes a quadrilateral to be a parallelogram, and then look at those properties and try to use them to then use the proofing of what a parallelogram is, right? So that you can write out that proof. But please remember, guys, whenever you're doing geometry, you always need a two-column table. First column, it is all about the statements that you are going to make. The second column will be the reasons why you think those statements are valid. So at all times, you need to make a claim, which is the statement, and then give me a reason why you think your claim is correct or valid. But for now, let's look at our leading question and then see how we can prove that a quadrilateral is a parallelogram. So as I said, my question is, how can you show that a quadrilateral is a parallelogram? What are the building blocks of a quadrilateral being a parallelogram? That's what you need to be thinking about, because that's what we are actually going to use. Let's just go through what geometry is all about. Remember, you always need to read through the facts part. This is about what the statement is telling you, right? In the quadrilateral, this side is equals to that side. And then because they have told you that, you will then mark that equality on your diagram, because everything that is given as a fact needs to be seen on the diagram. Then you mark the implicit facts. These are between the lines, right? So when I tell you that these lines are parallel, I am not giving you the properties. The implicit of the lines being parallel will be the properties of the parallel lines, your corresponding, your alternate, and your co-interior angles. Then you also need to read through the facts part. This has to do with what is it that you were given based on the implicit facts that we are talking about. And then you need to devise a plan of action. You also need to evaluate and then restart again. Now, the terminology that you're going to look at here is the implicit. Remember, I said this is normally the between the line, right? Between the lines. So, a typical example that I gave you, if I say to you AB is parallel to CD, you know that you can think about corresponding angles. That's the implicit thing. You can think about the alternate angles. You can also think about the co-interior angles. So these are not given from the get-go. The only thing I told you was that the lines are parallel. So the implicit part will be these three properties that I've just mentioned. Then also you have the word deduce. To deduce would mean to make a conclusion. So this will be make a conclusion based on what you have done in terms of your working out, right? Based on your working, based on your working. That's what you are making a conclusion based on your working. And then what we then need to look at firstly, as I said, are the properties of a parallelogram. So remember, a quadrilateral becomes a parallelogram if both pairs of opposite sides are parallel, right? Not just one, no, both pairs. And then also both pairs of the opposite sides are also equal. So this is option 1, by the way. This is option 2. Then option 3 will be both pairs of opposite angles are equal. That will be my number 3 that I can try and prove. Then you can also prove that the diagonals bisect each other, because that's one of the properties of what a parallelogram is all about. Now, how to prove that a quadrilateral is a parallelogram? I have 5 options for you, right? You can prove the both pairs of sides to be parallel or to be equal. The both pairs of the angles to also be equal, but they must not just be any pairs of angles, right? It must be the opposite pairs, right? Not just any angle. Then you can also prove that the diagonals bisect each other. Now, the additional thing from the properties of a parallelogram is that you can prove that one pair of sides are equal and parallel at the same time. So what do I mean? If I say this is a quadrilateral, A, B, C, D, and I want you to prove that this is a parallelogram. If you can prove that AB is equals to CD, and also prove that AB is parallel to CD, then this will definitely be a parallelogram. But you can't say AD is parallel to BC, and then that's 1 point. And then your second point is AB is equals to CD. That does not mean anything, because there are a lot of shapes that have that particular property. Also, remember that whenever we talk about congruent triangles, right, this is not a direct way of proving a quadrilateral to be a parallelogram. But we can use this to try and talk about equal angles or equal sides in that particular shape. That will then take us back to my 5 options that I've given you of both pairs being parallel, being equal, the angles being equal, the diagonals bisecting. So you can use congruency to try and apply one of these options that I've given you here. Now, when you are proving parallel lines, because that's one of the other properties I gave you as an option, you need to be able to know that how can 2 lines be parallel to one another. And there's many ways to do this, right? You can use what we call the Convex theorem of parallel lines, meaning you can prove that the corresponding angles are equal, right? The corresponding angles, remember, that's like an F shape. You can prove that the alternate angles are also equal. That is your Z shape, not your U shape. So this is more like your Z shape in the diagram. And then lastly, you can try and prove that your co-interior angles are supplementary to each other. Now, a very fun thing, guys, that I actually saw sometime when I was looking at this. One person once said, these lines are parallel because it is the F property in the word fun, right? Because we normally shorten the properties of parallel lines to be fun. Please don't even try to do that. The F property does not exist. It's just a shortcut so that we help you remember how to then mention the properties of parallel lines and how to visually see them on shapes. So please don't try and do such things for us. Now also, in terms of diagrams of how these angles look, remember the red and the red there will be the corresponding angles. The purple and the purple will be the corresponding angles. So in simple terms, this will be my F that I was telling you about, right? Or my F will be this one going down, facing the right-hand side, right? Where you talk about the corresponding angles. But when you are trying to prove that the lines are parallel, please don't mention corresponding angles and leave it there. What about corresponding angles? They need to be equal in order to qualify those 2 lines as parallel. The other one is the alternate angles. Remember, you need to say that the alternate angles are equal in order to qualify maybe line AB to be parallel to line CD, if that was the requirement in that particular regard. So this will be red and red, those are equal. Purple and purple, those will be equal to one another. And then my Z shape that I spoke about will be like this, right? So this will be the Z shape that I spoke about, and this will also be the Z shape, my wobble that I'm gonna make for you here. Right, so that's how you look at the alternate angles. Also, you can try and talk about the co-interior angles, but please don't make the mistake of thinking co-interior angles are equal. They are actually supplementary, right? And remember, supplementary simply means that they add up to 180 degrees. Add up to 180 degrees, right? So if this angle here and that angle there add up to 180 degrees, then we will say that these are co-interior angles. And also if this angle here and that angle there add up to 180, we will then say that they are co-interior. So some people make the mistake of, because the first two properties are about equality, even when they get to co-interior angles, they think equality is what we need to look at there. So guys, please make sure that you understand what will make the quadrilateral to be a parallelogram, right? And one of those properties is to prove either the sides to be equal, to be parallel, the angles to be equal, the opposite ones, that is, the diagonals to bisect each other, or you can just use one pair of sides and prove that they are both parallel and equal to one another. We're going to apply this when we come back from the ad break, but for now, I just want you to digest everything that we've spoken about, and when I come back, I'll then try and apply this for you so that you can see how do you go about doing these proofs that we need to do. Please stay tuned, I'll be back just now.